Good morning. We are going to try to have a little discussion of the evolution of artificial intelligence and expert systems with a view towards its application, the audit domain. What you see here is a chart developed by Dan O'Leary from University of Southern California, published in JAMAIS, which is an evolution of work from the Gartner Group. And basically what the hype cycle says is that once a technology is invented and experimented with, it takes a substantial amount of time for this technology to evolve for practical applications. The chart actually shows different technologies and where they are in the hype cycle. As you can see, things like text mining, 4G, prediction markets, quantum computing are all the way in the left side of the S-curve, while things like voice over IP, text-to-speech synthesis are in a very mature curve. Although this curve shows different technologies sitting on this curve, what you can visualize is, for example, looking at your left, 4G. It progressively goes up until the technology is reasonably well known in its proposal, but actually in its practical applications is kind of waning because typically the technology is too difficult to implement with current infrastructure technology. And usually it will take some time, and I typically talk about 10 to 15 years, for a technology to go from the bottom of the S-curve in the left to more mature stages of evolution. And typically that is that hardware is not fast enough to support it, software is not complex and competent enough to support it, and very often the economics of the application haven't been quite matured. We are talking about artificial intelligence. Artificial intelligence has been discussed and evolved for many decades. And different kind of narrow domain applications of AI, including expert systems, have been on this S-curve for a long period of time. And I actually feel that the area of expert systems has suffered a longer than usual period of evolution, and at this moment is kind of on the bottom of the middle of the S-curve there, where you find XBRL, tablet PC, and etc., although XBRL seems to be substantially more developed than expert systems. Just to talk about history, Dreyfus in '64 classified artificial intelligence in 4 areas: game playing, problem solving, language translation, and pattern recognition. At that time, it predicted that in 10 years, a machine would be world champion of games, would resolve original problems, would translate language to non-detectable machine translation, and identify patterns very well. After '64, but still in the early '60s, professor from Stanford, Feigenbaum, reoriented the area of work in AI by focusing not on basic paradigms, but in identifying and formalizing human expertise, and then represented this as software. And this area was developed, was called expert systems, and became one of the 5 main areas of artificial intelligence. So in the early 90s, what we had, those 4 areas evolved into 5, and was natural languages, expert systems, cognition learning, computer vision, and automatic deduction. By the 90s, the predictions of a machine being a world champion of chess hadn't been materialized. Now, in the late, in the early 21st century, we actually have a situation whereby Big Blue has become the superior to a human chess player. And we'll talk a little bit more about that. But the other predictions that we see here, we really didn't have a lot of problems that were original problems that were solved with machines. Language translation is not embryonic, but is not fully mature. You find things like Google Translate that is quite adequate to do translations, but is not perfect, and certainly loses substantial amount of the subtleties of verbal speech. And it's, again, unless you know what kind of pattern you're looking for, machines are not very good in recognizing it. In the early 90s, it was very popular to talk a lot about expert systems. It became the most popular area of artificial intelligence. Something like 75% of all AI applications and commercials and prototype systems were expert systems. A whole family of software has been developed for that purpose. Actually, I published 6 volumes of a series of AI and applications in auditing. Since then, the film has been reasonably dormant. The big 4 firms had developments in and had proposals and had systems in the expert systems area. These days, they are not doing very much in this area. And we might kind of see a resurgence, but not directly with the firms, but what I expected to happen is to separate vendors developing expert systems and selling it like it has happened with computer audit software, whereby each firm had their own software package of IT audit, and now basically companies like ACL and IDEA sell this software for many firms to use. Going back to the 60s, McCarthy, who was a professor at Stanford, basically told the Pentagon backers that constructing artificial intelligence machine would take about a decade. 2 decades later, in '84, basically that was not really true, and still today is not true. The basic issue is understanding what intelligence is, what knowledge is, and basically how to replicate it. Knowledge has substantial obstacles on its utilizations. First is this whole idea whereby knowledge can be private and you don't want to divulge it, or knowledge is public. And once the knowledge identifies, there are a whole set of representing it. The other issue is that much of the knowledge is unconscious. You understand, you have rules of thumb to do certain types of things. You don't really know that you have that kind of knowledge. Substantial amount of work in knowledge engineering, whereby you try to capture knowledge out of experts, tries to address of capturing unconscious knowledge. My personal experience trying to do a series of efforts of capturing knowledge from experts basically says that experts tell you that they really don't have a rule for doing things, and depending on the circumstances, they will rationalize what it happens, but in reality they have a large set of rules, and when you present them with cases, they will blurt out some of the knowledge that they have. And that's one of the reasons why you actually liked very often to do knowledge elicitation with examples, because experts work much better with that type of thing. And so this area of knowledge engineering has been evolving, and there are tools that have been developed for it, and also has been kind of a little bit quiet in the last couple of decades. Now, let's just talk a little bit about what is an expert system and what can it do for you. I have a chart here on slide number 9, whereby shows a very rough architecture of expert system, whereby there is this thing which is the core of an expert system, which is called the inference engine. And the inference engine basically resolves the inconsistencies or the sequencing of if-then rules that are impounded into the expert system. Although expert systems in the early years have been mainly deterministic, whereby if A happens, then B is the consequence, etc., etc. These days, you can create inferences based on probabilistic and fuzzy set type of logic. The key architectural item on expert systems is your ability to represent knowledge. And also, in this representation of knowledge, there is a substantial concern given to status of systems and identifying the status, what we call actuals, into knowledge around it. Interesting phenomenon that has happened with expertise and expert systems is that in one sense, many rules were started to being impounded not into expert systems, but into traditional data processing systems. Many of our studies actually, after aberrations or anomalies are found, auditors, internal auditors in this case, will recognize as aberrations, say, don't worry about that particular problem because it's intercompany transfers, or it's something that we know, or it's something that's legitimate. And typically, in order to filter data for deeper data analysis, you put some rules in the front of the system to exclude those aberrations, those anomalies on the system. And many systems today, like in ERPs, actually are very, very rich in a series of expertise that is built around the system, not only pure processing power. 2 or 3 decades ago, several of the firms had expertise. The then Big Six, pretty much each one of them had some experiments in expert system. These days, you don't really find any systems in the Big Four as far as you know, but obviously many of the firms don't publicize very much some of the internal processes. Now, we feel that there are some applications of great promise. I listed a few of them: assessment of bank loans, tax accrual evaluation, audit planning, audit risk assessment, computer control assessment, system monitor, just to mention a few. Now, just to kind of recall what was being done in expert systems, several of the applications were medical, and the granddaddy of them all was the JAMAIS application, which basically was for detecting blood diseases. And then a diagnostic engine that they called Internis was used as an illustration. Since then, whole set of specific domain applications like Schlumberger's oil exploration or the VAX configurator, maybe 3 decades ago, were applied. The VAX configurator actually had something like between 10 and 15,000 rules built into it. And these were pretty pedestrian type of rules, and the engine was easily developed just to deal with a large amount of minutia that is necessary for configurator, which wasn't particularly good for human brains to debug, to deal with. Humans would tend to forget the details. And so that was a reasonably good application used maybe in real time. Another interesting expert system application that is very real even today is basically credit evaluation. The large credit card company like American Express actually use a hybrid complex version of commercial systems that have expertise to decide on the concession of credit to particular each transaction within the parameters of that particular credit card situation. Obviously, the firms are a little bit discreet about how they do this because obviously they don't want people to game the system. Just as also kind of a historical discussion, in the 90s, about 3/4 of the AI efforts were in the expert systems area, and there were tens of thousands of them developed in the US. And many of them were developed with very simple software. The most popular of was called VP Expert. But there were a whole set of expert system shells, which were basically environments for which you could build rules easily, impound rules easily, and there were algorithmic conflict resolution and rule resolution tools that were used in addition to an explanation element to it and maybe some direct contacts to databases. Now the interesting question is what happened with these applications, and although this has not been fully researched, it seems that many of these applications were basically supplanted the S-curve and are basically impounded in traditional software, many of them actually in ERPs. Now, application of AI in auditing, and we are going to now talk a little bit about just some potential application of AI in auditing, and then what I'm going to do is talk about some modern AI thinking, and then try to speculate a little bit on what really should happen in auditing, although it's not happening at this particular moment. Two areas of actions could happen in auditing, analogous a la information systems or a la audit software. One is auditing systems that are intelligent. Second, using intelligent auditing tools. And the first one is inevitable when systems evolve, and it's already happening to a certain degree. And I find that our current audit technology is basically clueless on dealing with auditing systems. And we still haven't done too much in developing intelligent audit tool. We're going to talk a little bit about what these tools should be developed. Although intelligent systems are still not prevalent, they, however, are deterministic in production areas. So what does that mean is that there is not a lot of probabilistic and fuzzy set inference at this moment in systems, therefore they are not terribly intelligent. And I say here that auditing is getting into AI is actually probably very optimistic. One of the methodologies, and actually I'm going to talk about case-based systems and neural systems, because I think these two things have some promise. And typically what you try to do in a case-based system is formalize, is prototypize, create frames that represent types of cases, and then create a solution for this case and Anytime you input a problem, you see if it falls into existing case or you create a new case. Reasonably simple to talk about, reasonably complex to be done. The other thing that is interesting about case systems, case-based systems, is that allow us to create frames that you keep repeating the rules that you have before, as opposed to treating each case independently. Easier to said than done, and there has been in the past a large literature on case-based reasoning. However, this really requires a substantial amount of formalization, which is very, very difficult to do. Just the key problems on case-based reasoning is how to represent things, how to index, storage, and retrieve, how to adapt a case that's reasonably similar to a particular generic frame, and the ability to learn from a case and generalize from the case. These are obviously all areas of research which could be very interesting in the artificial intelligence area. Interesting, and we should mention a little bit this idea of intelligent agents. What is an agent? Is a particular device or a person that does something in your behalf. And there is a whole set of potential agents that have been developed in the last decade and a half, since the internet, particularly the World Wide Web, became ubiquitous. Many commercial applications have been developed that behave like intelligent agents. But the capabilities of these agents are reasonably pedestrian at this stage. Just to give you some examples, developing an agent for email handling, an agent for scheduling meeting, an agent for electronic news filtering, an agent, a recommendation agent. And the moment I describe these agents, you start identifying things that you have seen in the internet that you might be using, etc., etc., etc. And they now, as you can notice, some of these agents are basically impounded on day-to-day usage software like Outlook, or there's several Microsoft agents that exist there, and certainly in many of the Google tools. One thing you will notice that many of these agents are very deterministic, and they are very simplistic in approach in order to be able to deal with the problems we talked before of representation of knowledge and et cetera, et cetera. One of the things that you start using Google software that has several kind of behavior agents on it is that your options of what you do with that particular agent are very, very limited. They are particularly known for the paucity of alternatives. And of course, there are other kind of things that you can enable agents for, and keep in mind this idea of an agent. The agent is a little piece of software or a larger piece of software that performs a function for yourself. And advancing a little bit the discussion of auditing in relation to explicit artificial intelligence, the idea of an intelligent audit is an idea of cutting the audit into small little pieces and figuring out the ones that can be automated and the ones that can be delivered by some kind of agent. And when we talk about the audit data standards, you should have in your mind the idea of small agents to help in the usage of the standard. Now, an area that has been extensively discussed is this area of neural networks. And neural networks were considered some kind of element of artificial intelligence in the past. In reality now, neural networks are basically an algorithm, one of the several algorithms that you can use in the area of machine learning and data mining. Now, although neural networks have this kind of idea of being analogous to natural intelligence, I think this is pushing it. It's really it has these elements, it has these interconnections, but it doesn't have the chemical components and the real representation that the brain does. It actually finishes up, as I said before, more of an algorithm than anything else, and can be compared with many of the other multivariate methods, and they have been, in certain circumstances, considered better, in certain circumstances considered worse, basically based on the pattern of that particular domain. Just one more thing to mention about neural networks. You basically, in order to use a neural network, you need to have a situation where you have definite outcomes and you have recorded these outcomes. So you basically need what's called a training set. And basically a training set creates multivariate equation that explains to a certain degree the outcome that you receive. So basically things like stock performances and et cetera, with a large history of stock behavior and the outcomes, what the stock did, and the related variables allow you to create parameterized equations that try to explain that particular thing. And basically there is algorithms to create what's called a hidden layer that is basically link the cues that you receive to the outcome that you have predicted. So most of the usage of neural networks, you have a data set that has diagnosticity, meaning is a data set whereby you have labeled outcomes, and you train, which means creating the parameters related to the cues to relate to the outcome. And then you can use that as a predictive model that has been parameterized before. Just for a little aside, which is relevant here, not into neural networks, but more into the area of expert systems. We have at AT&T developed the system called the continuous process auditing system, and that went on from 1986 to early 1990. And what that system was an attempt to understand any type of faults and difficulties with the billing system of AT&T of that time. And basically the method developed for that was a method of creating rules that were captured from experts. So basically two of the senior, more experienced auditors of billing systems were pulled aside from the regular activities and were interviewed deeply using some of the methodology that I discussed earlier in order to capture what would be the rules of thumb that they used for identifying problems with the billing system. That said, we also had to draw on the architectural competency of a lot of IT people and architects, because the auditors really understood reasonably well the data, but they didn't understand architectures and how the computer system works. So we finished up developing the system. The system was oriented towards the way auditors think, which is basically flow charts, and behaved a little bit a la hypertext, like we do today in the internet, whereby you just clicked and went to the different levels of the system. And in that process, we actually captured data out of operational reports of AT&T, filtered them out into relational database, and parameterized certain levels of the graphs being presented in the workstation. And many rules that we developed from the auditors were basically impounded on the system and were activated either by an event, by what we called a daemon. And so basically, if certain type of things happen, certain analyses were activated, or something that we call the cron, and these are two notations out of the Unix world, whereby frequently, let's say every 5 minutes or every hour or every day, a certain procedure was activated. And the system grew in complexity while you were growing, capturing knowledge from the experienced auditors. Interestingly enough, one of the auditors retired, and we brought in another auditor, and he was less experienced, and we found that really didn't have as many rules to capture for them from him. And so our conclusion, based on just anecdote really, was that that experience created deeper understanding and the ability for generating much more rules. Still, auditors needed to be prompted, presented case, presented data, talked about events until they kind of proposed rules. And very often they would say, I will do this in this case, and you say, why? And they say, I don't know the reason, or seems that like a good idea. And then you dig a little bit deep, a little bit more. There were a series of conditionants, because this particular field is filled and the value seems to be high in relation to that. They always had, even when they said there was no reason for it, if you dig deep enough, they had a series of reasons why they did things. Our experience, more my experience of that time, trying to develop 3 or 4 of these systems, was that most experts were very modest about their capabilities initially, and progressively they get very impressed that they did have a pile of rules. And the other interesting thing is that when you presented them with a graph like this and the reactions of the system, they would develop new rules on the fly. So we always had this discussion, don't be afraid that you'll be replaced. Your role will be improving the system, not replacing you. That was the generic idea. I'm not totally sure how candid we were with that, or if we really knew what the answer was. I have in the next couple of slides that I just included here a little bit of a kind of a history of artificial intelligence in a wider domain. And I just included them here for you to kind of understand that there is a lot of law around artificial intelligence, and however the real usage of artificial intelligence is very much in narrow domains. I tend to, for example, ask my students the following question. Do you prefer to be diagnosed by a computer or by a person? Next question I ask is, how would you feel if you're sitting in a doctor's office talking about some health problem you have, and he would go into the computer and try to use a diagnostic machine? And everyone is ready to throw up with that particular idea. Actually, I think I'd much rather have a good diagnostic engine look at my symptoms than a doctor who really don't have so many variables that he can mentally process. Same thing I feel about landing on an airplane, for example, whereby machines can land it. And most of the people's objections come is a person can deal with fuzzy situations. What does it mean is that if something that has not been predicted on the development of the particular system occurs, a human being can improvise in a better way. I don't know. It's my personal feeling is that those improvisation situations are very, very rare, and I better have a systematic treatment of my symptoms or of my situation, like landing, by a machine that covers 99.9999 of the situations, then being ready for the 0.0001, that is something that will not occur very often. So that's very interesting. The other discussion we always have about AI applications, let's say, for example, landing a plane, is that, if you have computer software running diagnostics on a real-time basis, you can use measurements and do reactions on a real-time basis or close to real-time basis, which you couldn't do with the person interference on the system. And this discussion is actually applicable to this whole area of using audits, using agents and using different audit applications close to real time and interfering in systems or obstructing systems or reacting systems in real time. And the discussion in auditing is a little bit less glamorous than discussing medical diagnostics or game playing or robots and etc., but is related to it. So I had this kind of, I put this kind of historical story here about AI, and actually it's very interesting to discuss in class artificial intelligence, because very often people start associating artificial intelligence with what we have in the corner here of the slide, which is little robots, human-like, doing things for you. And in reality, AI type of work is a whole set of softwares that doesn't have anything human-like, but typically the complex interaction of the modules will have sometimes very non-intuitive type of reactions, which sometimes are very relevant and the humans could never process it. Sometimes they are not relevant, and sometimes they become nonlinear, and that's the 0.001 that we're talking before. Like any type of technology or like any type of human behavior, experience with its usage will allow you to exclude the unacceptable nonlinearities of the outcome. And today there is a lot of use of small AI type of applications in business, in cars that drive themselves, in medicine, in household items. And sometimes they're called AI, sometimes they are not called AI. And I have a whole set of explanations here of utilizations of artificial intelligence type of devices. But as you see, the components are not really discussed very often as AI type of components. And here, just for the fun of it, I included some of the AIs that are AI in computer games, and I am sure that you recognize several of these. The major story around here is how much money was actually involved in 2010 in this gaming. And if you have been watching the press, like today as we talk, end of 2012, you have seen that the whole new generation of more human-like, more interesting games are just emerging, and some organizations make a lot of money on it. A lot of organizations losing a lot of money on it, because the hit ratio of good games is very low, because a lot of people developing these games. Now, the other discussion that I constantly have in class about AI is what is really intelligence, and how do you know if a machine is thinking like a person? And the classic test is what they call the Turing test. And the Turing test was very simple and interesting test. You basically have an interrogator, it could be anyone, asking questions, and you would have a computer and a human being answering it with written communication. And the machine is really intelligent if you can't distinguish in a complex set of questions which one is the answer of the human being and which one is the computer. And although there have been some successes on this thing, we still haven't found many intelligent machines. So there is a whole area of challenges on AI type of law. In the legal area, in the technical area, in the social area, and we're going to talk a little bit about the singularity next, which is not next, but which is quite interesting, and some ethical issues. This guy, JAMAIS CASCIO, is a futurologist, and he talks about artificial intelligence, information technology, and virtual reality, and basically said that to change human existence as it comes. And basically said that you need to put together some people that worry about social issues because technologies cannot deal with it. And actually there has been a group pulled together, many groups, but a particular group pulled together that discuss extensively this idea of the singularity. And the singularity, in theory, is this idea whereby machines become more intelligent than people. And although this is a little bit on the sensationalistic side, it's actually interesting to think about the concepts. And when my students react against this idea, my reaction is always, how fast can you do 3 digits versus 3 digits multiplication in your head? And of course, machines do that much faster. And if you have any process that is highly computationally intensive, machines do much better than people. And then we can go to other discussions where humans are superior to people. And in many of those discussions, you also come up to the situation that maybe machines will be better than people in a little while. Now, that said, there is a whole other set of issues related to machines versus individuals that arise, but I don't think it's directly from importance at this particular point. Now, when you talk about the responsibility that you don't leave technology only for technologists, you talk about, I like to quote JONAS, the inventor of the polio vaccine, talking about being a good ancestor. Being a good ancestor becomes especially challenging when we recognize that even small choices matter. It's not just a multi-billion-dollar project and a mistable world-altering idea to change life for our descendants. Sometimes, perhaps most of the time, profound consequences can arise from most prosaic topics. And this is actually something that you should try to think and wonder relating to audit. A lot of very prosaic things are decided in auditing standards. And the interesting question very often to ask is this particular standard developed for ultimately developing more reliable systems or more reliable financial statements, or the standards is developed basically for professional self-preservation and making us not very good ancestors, not leaving a good audit word after us. Going to the futurist, just want to read your quote. Video games, camera phones, Google Earth, and the myriad of day-to-day technologies that individuals may attract momentary inertia may also in combination offer us a way of grappling with a future world that will radically different from our own. Today, many scientists, researchers, computer programs, culture watchers, and futurists believe that in the next 4 decades, we will enter into a phase of sudden, rapid, and unprecedented technological progress, caused in part by the ability of machines to improve themselves using artificial intelligence. Now, for some, this is a very, very scary idea. You start thinking about machines dominating the world and people being relegated to the corners. There are films, there are the whole set of things that talk in that way. From my standpoint of view, it's actually quite good if we can spend our life just playing and let the machines do useful work, fixing roofs and driving cars and driving airplanes and doing security in airports and et cetera, we dedicating ourselves either to the exoteric or to just entertainment. Sounds pretty good. Obviously, there are a lot of other issues to discuss. I have captured these next slides talking about a little bit of these concerns that we have about the singularity. Repeating, the singularity has been defined by series of futurists as the time when machines develop better competencies than individuals. Here is a kind of set of questions drawn from that work that actually we start now to be able to understand them. Web 2.0 provides with all kinds of capabilities, and when you put games in Web 2.0, you start getting to a situation whereby real world and simulated world are somewhat interconnected. And of course, we have doing that with geospatial maps. In the audit area, we can do works like geolocational work, like, for example, identify Medicare or Medicaid fraud by the location of doctors and the location of patients, and link this to real things like diagnostic and prescriptions of drugs. And we can start linking different capabilities, some of them virtual, some of them real, some of them analytics, into what we call the metaverse, where you are linking simulated abstract worlds to the real world. And the most pedestrian of these applications these days is the tremendous expansion of the usage of GPS information in travel, and whereby the location of the individual identified by a GPS can be placed on a virtual map and can be simulated with routes, can do all kinds of different things, some of them benign, some of them very malign, like Big Brother is watching. However, the capabilities mind-boggling if you start thinking about it. When you metaverse, you typically break into 4 segments, and it's actually kind of good talking about it, because we can apply this pretty much directly to auditing. And if you start thinking about it, we're going to define what augmented reality, life logging, mirror worlds, and virtual worlds are, and then we start thinking about how we can apply this to what we will talk a little bit later about the ecosystem of auditing. First, this idea of surveillance. And the question behind that first wonder is, we have now cameras everywhere. And this camera, the question we ask ourselves is, what happens when surveillance merges with artificial intelligence? Today we have cameras, for example, in parking lots. And, but you need some guy sitting over there looking at the cameras, and you know, how many hours can you look with good attention span? And so basically you really need software to be able to identify something that is a threat or something that needs human intervention. And the software there has been software developed for that purpose, but it's pretty primitive at this moment. However, if artificial intelligence observers can be developed, this would be very, very interesting from the standpoint of personal safety, also very, very scary from the standpoint of Big Brother is watching about the individual privacy. Now, let's talk about those 4 quadrants. The first thing is this idea of a virtual world. And the virtual world is this whole thing that we have developed in computer systems, that people play virtual reality type of games. Virtual world, you kind of immerse yourself in games like the World of Warcraft, Second Life, Sony Home, and etc. This sounds like children's play. In reality, these are very, very important and useful technologies for any kind of dynamic behavior, including dynamic behavior of audit systems. And then you can represent real worlds like real audit system by mirror worlds that you basically are representing another world and use this representation characteristics for useful functions. Mirror worlds come from the international simulation and externally focused technologies. Just going down there, Google Earth is a canonical representation, present-day version of a mirror world. The Google Earth application uses magnified, easily enhanced satellite and aerial photographs to render almost any corner of the quadrant of the globe visible. And as you, I'm sure you have seen, Google Earth, you actually can link photography taken from street level to satellite-based photography with some very, very interesting, useful applications. At the same time, tremendous threat to individual freedom and to individual privacy. Now, another interesting thing is this idea of augmented reality. You know, if you are a football fan like myself, you know, you can go to Giant Stadium and see the Jets playing a game, and you could literally, with an enhanced reality, understand all kinds of information about that game environment that you couldn't see before, or you would have to have a lot of archival knowledge about the games. And this little picture just talks about identifying a person, which sounds very good. Name Lorna, friend rank 6, so we could put Chi Liu, name, friend rank 10, and then where she was located last, at what time, and what kind of sushi she likes, and that she likes the pink color. Okay, so you could have all that thing over there. And what is the in augmented reality really is basically the usage of sensors to identify real-time, real-life events, and the usage of some intelligence and some databases to tie additional information about that the real-life basis. Thinking about augmented reality, you can apply augmented reality to audit environments. Anything from observing a production line and identifying potential fraudulent behavior or waste behavior to auditing inventory, tie to product electronic identification, and et cetera, et cetera. Augmented reality, if invested upon, is a very useful tool for management of organizations and for their utilization. One thing that I found myself doing more and more these days, maybe is age or whatever, is I take a lot of pictures of everywhere I go. Yesterday, I went to dinner with a friend I haven't seen for a few years. I immediately clicked the picture, and she asked me, why are you taking this picture? And I said, so I remember what I did. Okay, and of course, if I had the software and the desire of cataloging this, I could develop some very interesting life logging type of things. And actually, I have done that, of developing a catalog of my diving with the sharks experience, and putting around that where we ate and what we did and what my daughter said, and et cetera, et cetera. And it's kind of very interesting because in one sense, this is enhanced. This is like photography on steroids. In the other sense, you're kind of turning your vision to the past. You're spending a lot of effort recording what you did in the past. And so there is an interesting type of thing. Of course, life logging is like process mining that we do in auditing. That's our most recent paper, whereby you pick up from a log of an ERP the stages and the activities pass to a transaction, and this transaction gets labeled, and you can look if that process was performed accordingly to prescribed obligations. And if it's different from the prescribed, you obviously have a potential of audit investigation. Now, process mining, as we have mentioned in many of our papers, is actually a different form of auditing, that instead of looking at the residual data, you're looking at what's actually happening. And of course, you could accelerate process mining to real-life process mining, whereby you would intervene or review fallacious processes or unusual processes while they're happening, maybe on a preventive basis. The whole idea of life logging is a very interesting idea, and basically depends on the levels of sensing that we can do these days. And of course, the better your sensing, the better is the life logging that you can do. However, it's very, very, at this moment, very, very difficult to do it, in the sense of takes a lot of time. And obviously it would be very interesting to have tools, software, and agents that actually life log for you, if you don't mind intrusion on your privacy. Now, just talking about singularity scenarios, are basically scenarios whereby we are getting intelligent machine type of behavior that maybe is superior to what we can do with our computational and our memory and the speed capabilities that we have. And I have 4 examples here, all tied to those 4 metaverse type of discussion that we had before. And then if the singularity is as likely and as globally transformative the way technologists believe, we really need a larger group of people, not only technologists, to deal with it. And actually, this is what the whole singularity, this whole singularity set of scientists has been looking at. And this guy, Werner Winch, has done quite a lot of discussion about the singularity. And the guy who has been more popularized about talking about the singularity is the guy called Ray Kurzweil. He actually has a very interesting documentary talking about the advancement, and it is not very different from technological prediction. Is extrapolation on machine power, extrapolation on memory power, extrapolation on capabilities, and he predicts that the singularity will be in 2050. However, you and me could predict it very, very different, and I think the whole idea to think that there'll be one singularity is close to nonsense. There is going to be different areas whereby progressively machines will do better than people, and people start relying on the machines to do that. And very often, very soon, you won't know how to do it, and so I won't be able to go and do my knowledge elicitation from my experts, because they will have no expertise, and we'll talk about that a little bit later. Okay, and this is just a little discussion out of The Economist, talking about the idea of the space Odyssey film, whereby a computer basically takes over a ship, a spaceship, and progressively dominates people. I just want to talk for a second about the idea of an ecosystem, because it's very important for audit thinking. Pioneers like Amazon has built cloud-based ecosystem that make content such as electronic book widely available. Even though the firm has its own e-reader, the Kindle and has hatched tablet computer. It's also created apps and other software that lets people to get the digital stuff on all sorts of devices, including PCs. And the reason I talk about ecosystem is that I think we need to develop eventually an audit ecosystem to support series of audit efforts. And just a slide here talks about other ecosystems like Google's ecosystem and Apple's ecosystem, which is the iCloud and etc., which all create a cloud-based environment to basically support a particular business concern. And obviously our business concern is auditing, and we need ecosystem support auditing if we're going to accompany what business does and be able to assure business in that level of complexity. And around here I have something from The Economist talking about basically saying what are apps and how many of them and how many downloads there are, and the numbers are totally astounding. And this is still growing exponentially. And it's a big business and et cetera, et cetera. And that said, we are going to live on a world of big data. And in this big data, business responds often on a real-time basis. I say the financial cycles are bipolar because a company internally runs ERPs and does a lot of response in inventory management, in cash management, etc., very close to the real time. However, the way they report to their stockholders and other stakeholders is on a quarterly basis. So obviously, the horse is out of the barn much before auditors get involved. And the real interesting question is can we maintain relevancy of assurance with this particular problem, with this particular situation? The answer is obviously no. And the question is, are we going to manage to change auditing into more intelligent type of system in order to be useful? We think that the continuous audit will be a highly formalized system, independent, basically of the first and second harmonic of human reaction interference. What do I mean by that? Is that some basic measurement and analysis a la expertise will be done by machines, and only exceptions of this will be escalated, which cannot be formalized or with a extant technology will be taken for people examination. And most of the auditing will be audit by exception, and most of our work will be building expert systems that will be able to deal with the little piece of particular automation that is needed. As the ecosystems that we are talking before, it's pretty clear that eventually we need to create an assurance ecosystem, basically to support assurance processes on a closer to real-time basis. And we have a set of questions here on how to design these, how to think about these. The first question is obviously, should they be embedded into corporate ERPs? And should they be separate pieces of software, or should they be like SAP's auditing layer? And then the second question is, what should be the frequency of their usage, and what they created, the creation of exception alerting type of things should be performed, how frequently should be performed. And usually we say that should be performed that each application has its own pulse, and the pulse determines the frequency of its assurance. The third thing is where should information be tapped? And the question is, should it be cloud-based? what are the security issues there, et cetera, et cetera, et cetera. Then the next question is, if you are using audit heuristics, how are you capturing this audit heuristics? And if these heuristics get automatically captured, after a while you lose the expertise that generated those that particular knowledge. And then we expect that a lot of the continuous auditing evidence will be alerting evidence, and the systems would have scores of their reliability or scores of how well they're performing, and how should this evidence being delivered, and etc. You could imagine that high stream of evidence would be delivered to some kind of filtering device based on individual evidence, and extreme evidence would be have a different alert basis. In the CPAS work, we actually had 4 levels of evidence, anything from just system measurements that were not performed, or some little blips in the system, to alerts that would basically stop the system, or alerts that would go to the auditor, alerts that go to auditor and management, alerts that go to stop the system. Then the next question is a question of standardization, and we have, if we look at history carefully, we started with big 8, each one with the audit software of their own. KPMG had 2190, Tushraut had Strata, and et cetera, and now if you look at where the scenario we are, we have 2 or 3 major vendors of IT audit software, and all the firms use it. And some standard on alerts, some standard on interface between the audit ecosystem and the different processes might be tremendously valuable. Now, it might be worthwhile to mention what we're going to talk a little bit later in the slides, the audit data standard. The ICPA's ASAC has proposed an audit data standard that basically just specifies out minimum of data that in every application should be provided to auditors, internal and external. And this standardization, meaning how this data should be presented and what data should be there, allows for the development of reasonably common and standardized apps that would allow auditors to basically assemble audit programs from pre-programmed, ready-made modules. And we think that in an audit ecosystem, we need a much higher level of standardization to allow ERPs, the audit ecosystem that would link together different types of ERPs, different types of audit procedures and applications, will need a much higher level of standardization. Actually, we tend to think that standard setting organizations should really focus on standards for interface between audit systems and audit environments, as opposed to detailed step-by-step audit guidance. We're very much anachronistic in many of the things that are already in place. And then the interesting question is how the economics of the audit profession, external audit, will integrate in this scenario. It seems to us that internal audit will be the driving force on much of the close to the event auditing within an audit ecosystem. And the question would be, how can those drivers connect to the economics of the profession? What we have here is automation scenario that may be feasible in these semi-smart or smart systems, whereby you're trying to link a set of audit plans with the traditional audit evidence and some modern audit evidence through the usage of kind of a hybrid system, which would have some kind of audit dashboard, a set of analytics extracting maybe mining type of information of systems, and then some other functionality associated with it. We actually think that the evolution in automation will be really more focused on audit plans and obviously automatable elements, and progressively more judgment-based auditing procedures. And so you could imagine that we work on what we call Lego-oriented audit or Lego audit, like this particular slide here. And the audit data standard would basically prescribe what the production data should be, what part of the production data should be extracted into some kind of common data repository for auditing purposes. I mean, some organizations today already have audit data marts or audit information locations or audit data warehouses. And but the advantage of having this standardized would actually be that you really could use a common set of apps. And we actually imagine that these apps are going to start basically from scripts of the audit software vendors like ACL and IDEA, and then progressively encompass some of the more complex or more frequent judgments that monitorers, most likely auditors, will perform on streams of exceptions that are coming out. We are going to be in this world of very big data, and sampling procedures on very big data are very, very difficult to perform and not terribly meaningful. So most likely they'll be very close to some analytics applied to entire populations. And these analytics starting with some reasonably simple, like exception rules, and very much the exception rules coming from heuristics developed from auditors, or obviously absurd type of data detection, to more complex judgments that auditors perform on these new forms of audit evidence and old forms of audit evidence. We also think that the apps are going to come in different colors or types, and some apps are being sold by the apps providers, other apps basically developed by large organizations, bartered among them, and the third set would be people contributing independent apps for completing particular functions. So what we have said here from the beginning is we defined a whole set of functions that were part of artificial intelligence. And we said that artificial intelligence evolved into basically 5 areas. The largest one was this area of expert systems. And this area of expert systems has basically disappeared from the regular literature, but rules and many of the concepts and the explanations out of expert systems are now in operating procedures in pretty much all large systems. And many of the rules are basically impounded in ERP controls and impounded into business procedures. Many of them are what we call today business intelligence, and basically they are rules of operation and rules of analysis and rules of exceptions impounded into systems. And this environment, which is a close to real-time environment, is very, very different from the traditional IT environments or manual processing. And unfortunately, audit procedures were derived decades before the particular environment of today evolved. The particular analytics that we can use today were developed, and the volumes of data that are involved in systems today. So companies in old times focused very much in their financial data. Today, companies basically run out of a whole set, expanded set of data. And what we think that's necessary in the expert system in the area of future audit environments is a whole set of expert audit monitors that serve as meta controls and serve as a form of data quality assurance to support the operation of modern business. Just it may be worth to re-emphasize that business technology get developed. This technology takes a long time to become operationally and economically viable. That's what we call the high curve. Now, once it becomes viable, business adopts it and is very much pressured to decrease the occupation of capital, meaning use less inventory, less time, and et cetera, et cetera. So business ultimately, in order to survive, have to incorporate this into their activities. However, although business incorporate this into activity, business reporting of the traditional form really doesn't incorporate many of these advances. They actually are nearly a parallel track of kind of a very slow parallel track to the actual business operations, making business reporting extremely anachronistic to what will happen in business. What actually happens is we finish up with dual personality type of operation whereby businesses run themselves internally on real-time activity and oodles of data, and then manually or close to semi-manually they prepare quarterly financial statements and one for everyone, which makes not too much sense. And then the assurance of this is what our profession, external auditors, provide, and so it's progressively less useful for business purposes, although some degree of even static verification, static assurance is desirable and interesting, but with financial statements becoming less relevant, their assurance became less relevant, except for very large, very 20,000 feet type of verification. Concluding, AI had slow evolution and is still a science in early stages. We actually had a lot of discussion about the idea of singularity, where machine intelligence will be more powerful than human intelligence. Expert systems that became the important area of AI now have basically been impounded into regular business applications very often in the form of what we call business intelligence. We also looked at the idea of case-based reasoning and neural networks, very important tools on the old traditional examination of expert systems and artificial intelligence, and basically said the neural networks are really an algorithm of multivariate analysis and a method to deal with tag data. Case-based reasoning is actually a good way to classify and work on known classifiable events. Now we think that within the audit ecosystem there'll be a plethora of intelligent agents performing exception detecting and other functions to facilitate kind of manual pedestrian activities of auditors to reasonably complex activities linking judgments to objective data in the corporation. And so basically there are still major quandaries on this evolving paradigm, but it's very important to say that intelligent or semi-intelligent expert modules need to be developed for auditing rapidly to fit in what we call this Lego audit of the future in the audit ecosystem.